Good morning, my dear children. Today we can be discuss about that some of the book back problems. It's a page number, textbook page number 230 and 231. We have some problems. Let us, I am going to start from problem number 19. It's a page number 230. Our lesson is unit number 7, chemical kinetics. Okay, unit number 7, chemical kinetics. Problem number 19. A gas phase reaction has energy of activation 200 kilojoules mole inverse. If the frequency factor of the reaction is 1.6 into 10 raised to 13 second inverse, calculate the rate constant at 600 Kelvin. So you have to calculate the rate constant at 600 Kelvin. You have to calculate. So all of you know that one, the formula. What is the formula? Already we discussed about that formula. So K is equal to AE power minus EA by RT. This is the formula. Here, what is about the EA? What is about the value of EA? EA is equal to, that's the energy of activation. EA means the energy of activation. EA is equal to 200 kilojoules mole inverse. That we can be written as 200 into 10 raised to 3 joules mole inverse. What is the value of E? What is the value of E? There is also given the question. E, the power minus 40.09 minus 40.09, the value is approximately given as 3.8 into 10 raised to minus 18. Here, what is about the T? T means the rate constant at 600 Kelvin. 600 Kelvin. T is equal to 600 Kelvin. Here, what is about the R? R is equal to 8.314 joules Kelvin raised to minus 1, mole raised to minus 1. Next, what is about the A? A is equal to, that's a frequency factor. Frequency factor A is equal to 1.6 into 10 raised to 13 second inverse. So I told that the formula for this problem is K is equal to AE power minus A by RT. So we are going to substitute here. Each one values are given. So K is equal to, what's the value of A? A is equal to, that is 1.6 into 10 raised to 13. What is about the E value? E value also that is given is power of minus 200 into 10 raised to 3 divided by minus of 200 to 10 raised to 3 divided by, what is value of R? See, 8.314 into T value 600. So we can written as that is equal to K is equal to 1.6 into 10 raised to 13 into E power minus 40.09. That is equal to 1.6 into 10 raised to 13. Here this approximately value is given, that is for minus of 40.09 can be written as 3.8 into 10 raised to minus 80. The question is given. So we are multiplying 1.6 into 3.8. 3.8. 1.6 into 3.8, we get the value is 6.7 8. Okay. Next we have to that the power value have to find out that one. Here having 10 raised to 13, here having 10 raised to minus 18. So we get the value is 6.08 into 10 raised to minus 5 second inverse. K is equal to 6.08 into 10 raised to minus 5 second inverse. That's about the problem number 90. Next we have to find out question number 20. What is about the question number 20? You have to read the question number 20. For the reaction 2x plus y gives L, find the rate law for the following data. So here having one of the tabular column, tabular form, xm, ym and rate. So each one have the value for the x 0.2, 0.4, 0.4. What is about the y value? About 0.02, 0.02, 0.08. And also the rate is also given 0.15, 0.30, 1.20. These are the tabular form. So we have to write the rate for this equation. What is the equation? 2x plus y gives L. 2x plus y gives L. Now, rate is equal to K into concentration of X power N, concentration of Y power N. M. Rate is equal to K into concentration of X power N, concentration of Y power M. So, as per the tabular form, please look the tabular column, all of you. The rate value for the first one, is 0.15. That is equal to K into, what's the value of X value? Look the tabular column. X value is 0.2, the power N. What's the value of Y? 0.02 power M. 0.02 power M. That's equation number 1. What is about the equation number 2? How can you write the equation number 2? The rate can be written as for as per the tabular column. 0.30 equal to, as per the formula, K into, what's the value of X? 0.4. So power N into, what's the value of Y? 0.02 M. 0.02 M. That's about the equation number 2. Next one. As per the tabular column, rate, the value is about 1.20. 1.20 is equal to K into, what's the value of X here as per the tabular column? 0.4 N. 0.4 the power N into 0.08 power M. As per this tabular column, we wrote that 3 equation. Now, we can divide equation 3 by 2. Equation 3. First, you have to take equation number 3 by 2. What's about the equation number 3? That is about that. Here, 1.20 is equal to K into 0.4 power N, 0.08 power M. So, you have to write the first step. Equation 3, that is 1.2, that is equal to K 0.4 power N and 0.08 power M divided by, what's about the equation number 2? Equation number 2 means here having equation number 2, so you have to write 0.3, that is 1.2 divided by 0.3 equal to, next about the k into 0.4 the power n, and equation number 2, that's m value is about 0.02, not 2m. So which are the possibility for cancelling here? That is about that k into concentration of 0.4 divided by k concentration of 0.4 can be cancelled. So I am going to cancel here. What's about the remaining? Remaining, we can be right. 4 is equal to 0.08 divided by 0.02 the whole power m, whole power m. Here 4 is equal to, just we are cancelling, we get 4, so 4 power m. So what is the value of m? M is equal to 1. Value of m is equal to 1. Next, as per the equation, 2 divided by equation 1. 2 divided by equation 1. Okay, please check the tabular column. Equation 2. What's about the equation number 2? The relative value is 0.30 and the m value 0.4 and the y value 0.02. And you have to write equation number 1 also. That is rate value 0.15, x value 0.2 and the y value 0.02. Here also, which are the possibility for cancelling here? 0.02m and 0.02m can be cancelled. So 0.30 divided by 0.15, cancelling we get 2. So 2 is equal to k also cancel here. Remaining we are having 0.4 divided by 0.2 the whole power n. So 2 is equal to 2 the power n. So n is equal to 1. Next, the last step, rate is equal to k into the concentration of x and the concentration of y. We have to write the power 1, x power 1 and y power 1. So I am going to write about that from the tabular column. The first one, that is about that rate is equal to, all of you know that one, rate is equal to k into x power 1 and y power 1. So what is value of rate? Rate is equal to 0.15, that is equal to 0.15, that is equal to k into what is the value of x? 0.2 the power 1, and what is the value of y as per the tabular column? 0.02 the power 1. So we can be take k is equal to 0.15 divided by 0.2 the power 1, 0.02 the power 1. Just multiplying the first 0.2 into 0.02. 0.2 into 0.02, we get the value 0.004. 0.004. So just dividing 0.15 divided by 0.004, we get the value is, that is equal to 37.5. 37.5 mole inverse liter second inverse. Mole inverse liter second power 1. Okay. That's about that. The 20, question number 20. Now come to the question number 23rd. The rate constant. Question number 23rd. The rate constant for a first order reaction is 1.54 into 10 raised to 3 minus 3 second inverse. Calculate its half lifetime. We have to calculate the half lifetime. Very, very important question. This is one of the board examination questions. So try to learn this question. The half-life period formula is that is T half is equal to 0.693 divided by K. T half is equal to 0.693 divided by K. So as per the value K, there is a rate constant for the first order reaction that is given as 1.54 into 10 raised to minus 3 second inverse. 1.54 into 10 raised to minus 3 second inverse. Calculates its half-life period. Okay, now we have to write the formula. T half is equal to 0.693 divided by K. Next substitution, T half is equal to 0.693 divided by 1.154 into 10 raised to minus 3 second inverse. That is equal to 0.693 divided by 0.693 divided by 1.54 into 10 raised to minus 3, that we can be written as that is equal to 0.693 into 10 raised to 3 divided by 1.54. 1.54. Now I am going to multiplying 0.693 into 1000 divided by 1.54. So I get the value is 693 divided by 1.54. Again multiplied by 100 above and below. That is 100 below 100. So we get the value 69300 divided by 154. 154. So approximately we get the value is 450 second. 450 second. Next, please all of you take the question number 24th question. Question number 24th. The half-life of a homogeneous gaseous reaction SO2Cl2 gives SO2 plus Cl2, which obey first order kinetics is 8.0 minutes. How long will it take for the concentration of SO2Cl2 to be reduced to 1% of the initial value? We have to find out 1% of the initial value. So which are the given data is given. The concentration of SOCl2, the concentration is about that 100%. That is A0 concentration. A0 is equal to 100%. And A, the concentration of A become 1%. A is equal to 1%. Next, which are the given data? T half is equal to 8 minutes. T half is equal to 8 minutes. T 99% is equal to, we have to find out, that's a question mark. So we have to use one formula, that's about the K. first order kinetics formula. K is equal to 0.693 divided by T half. K is equal to 0.693 divided by T half. So the given T half is equal to 8 minutes. So we have to divide 0.693 divided by 8. 8, that is equal to 0.693 into 1000 divided by 8 into 1000. So if you are dividing, K is equal to 0.693 divided by 8. Just we are dividing, we get the value 0.087. 0.087 minute inverse. T is equal to 2.303 divided by K. T is equal to 2.303 divided by K log A naught by A. A naught by A. Next step, T is equal to 2.303 divided by the value of K. K is equal to, already is given that 0.087. 0.087 into log 100 divided by 1. Log 100 divided by 1. We know that on 100, we get the values 100. 100 can be written as 10 square. Okay, like that we have to write. So T is equal to 2.303 divided by 0.087. 0.087 log 100 square. 100 square. Again we can be written as T is equal to 2.303 divided by 0.087 into 2 log 10. 2 into log 10. So T is equal to 2.303 into 2 divided by 0.087. Just 2.303 multiplied by 2 means we get the value is 4.606 divided by 0.087. That's equal to 52.94. 52.94 minutes. 94 minutes. Next question, question number 25. Question number. The time for the half change in the first order decomposition of the substance A is 60 seconds. Calculate the rate constant. How much of A will be left after 180 seconds? This is one of the important question. The time for half change in the first order decomposition of substance A is 60 seconds. Calculate the rate constant. You have to calculate the rate constant. How much of A will be left after 180 seconds? That's a question. So first, which are the given datas? What are the given datas? We know the formula. T half is equal to 60 seconds. So we have to find what is the value of K. Already we know that on T half is equal to 0.6932 divided by K. K is equal to 0.6932 divided by T half. Now we can written as that is equal to 0.6932. 0.6932 divided by The t half value is also given, that's a 60 second. 60 second. Next, we get one of the value. What is the value is about that? 0.693 divided by 60 means we get approximately value is about that 0.011 5 second inverse. 5 second inverse. Next, t is equal to 180 second. Now we find out for the t for 60 second. Now for the 180 second, t is equal to 180 second. 180 divided by 60, that is approximately we get 3 into t half, 3 half, 3 t half, 3 t half. So 100% gives first t half 60 second. Next step can be written as 100% gives first t half, that is a 50%. 100% to 50%, that is a half time, okay? 100% to 50%. Next 50 to 25%. Next 25 to 12.5%. That is a half. 100 to 50, that's a one half. 50 to 25, next second half. Next 25 to 12.5, third t half. Okay, like that we have to write 100% first t half 50%. Below you have to write 60 second. Second t half, it is goes to 25%. Again we have give the 60 second. Next 25 to again 12.5%. That's the third t half 60 second. So now you count the time. That's the second 60 second. First 60, next again 60 means 120. Next again 60 means 180. So what is the value given? That is after 180 second, 12.5% of A will be left over. A will be left over. So what's our answer? About that 100% to 50, 50 to 25%, 25 to 12.5%. That's a time A will be left. How much of A will be left after 180 second? Next question, question number 26. What is about the question number 26? A zero order reactions is 20% complete in 20 minutes. Calculate the value of the rate constant. In what time will be the reaction be 80% complete? That's a question. Question number 26. The first one you have to write, which are the given here. Let A is equal to 100 m. A is equal to, that is, let A is equal to 100 m. A naught minus A is equal to 20 m. For the zero order reaction, we have to write the formula. K is equal to A naught minus A divided by T. So K is equal to 20 m divided by 20 minutes. That is equal to 1 m minute inverse. Rate constant for the reaction is equal to 1 m minutes inverse. Second step, what is about the second step? We have to calculate. To calculate the time for 80% of completion. Time for 80%. This K is equal to 1 m minute inverse. That already we find that one. What's about the A0 value? A0 value is equal to 100 m. A0 minus A is equal to 80 m. You have to find out the value of T. T is equal to how to find out, that is can be given as question mark. T is equal to A0 minus A divided by K. That is about the A0. A0 means 100. A means 20. So 100 minus 20 means we get the 80. So 80 m divided by K value, that's K is about 1 m minute inverse. So we get the value is 80 minute. 80 minute. Okay. Next. Please try to learn this question, all of you, my dear children. These are some book bag question. You have to learn the book bag question. So I am giving about the today assignment. Assignment question. Question number 23. Question number 24. And about the question number 25. These three questions for the assignment. 23, 24, 25. These three questions. Try to learn, my dear children. Try to learn this question and write the assignment. Thank you, all of you. Thank you. Have a nice day.